Now the topic is a mouthful: background processing and real-time Vaadin applications. This is a topic that, for some reason, lots of people are asking about it on Stack Overflow, and for some reason I'm usually the one who answers those questions. So I'm here trying to kind of slightly reduce the number of questions we get by actually letting you learn all the dirty secrets. What we're going to talk about, again, there's always 3 points on the agenda for some reason. First, talking about polling for updates, then pushing out updates, and then continuous updates. We'll get to see what each of those mean, but there's kind of making things a little bit more complicated for each step here. The first part where we start this journey is with polling for updates. What we really have here is we have users, and users, they're always, or they're never patient. They're always kind of, can I get this now? I don't want to wait until later, and so, and then keep asking, is it done yet? Is it done yet? And all those things that users do. And wouldn't it be easy without users, by the way? Yeah, I know. But really, instead of just talking, I'm going to show you lots of practical examples here. So let's first just see like what's going on here. We have this, of course, we must have a Hello World application to start from, so just click a button and it says hello, and the code is really, really complicated here. And what we're going to do, and what you often do in your applications, is that you have something that takes a while to run. Maybe you're generating some report, maybe just running a really slow database query, maybe you're waiting for external system, or maybe even waiting for some other user to react to something. Whatever it is, you have something that takes a while and you're waiting. I didn't even bother to make up a real example, so I just have a general, like, I have a slow thing to do. I have a slow job. It's 2000 milliseconds slow, so 2 seconds. That's my job. And I'm starting this in the click listener, and then once it's done, I'm gonna do job get the result. No, actually do it is the thing I wanna do. Just start the job, wait until it's done, and then we get a result out of it. And then finally, once it's done, I want to show to the user that now the thing you're waiting for, now it's actually done. So I'm gonna take this message label that we're already showing here and update the value of it. And show the result from the job. When I run this in the browser, I click the button, nothing happens, and then suddenly it pops out. But we did never see this button click label. We never got the confirmation that, hey, now the job started. It just, if you were really, really observant, you see there in the top bar, there's a progress bar, and then suddenly it's done, but nothing happens in between. What really goes on here, why we don't see that label? To understand that, we need to see how Vaadin works behind the scenes a little bit. So actually in the browser, there is, this is based on Vaadin 8, by the way. When I actually click the button, there is this button server RPC, which is an RPC proxy which does things. What it does is basically that it sends a request to the server saying that, hey, now this thing happened, and then server-side logic, still on the framework, finds like, okay, it's targeting this button, instructing that button that, hey, run your click listeners, and then our application code runs. All that runs, and then when we actually return from the click listeners, there can be multiple listeners and multiple events. Once that has happened, we have processed the entire HTTP request, and then Vaadin starts writing out a response. That response then contains like, oh, update this label and so on, and then that gets processed in the browser by the client side, and only then we see what actually happened. And the problem here is that everything happens during that same request. We cannot do kind of more fine-grained things here. It actually gets even worse than that. So next demo, let's have a look at those requests actually. So if I open the browser inspector, and now I will gonna do such a trick that I will click the button 5 times. 1, 2, 3, 4, 5. And then we wait. There we go. So what happened here was that the first time I clicked, there was a request for the button click. It was sent to the server, and I was clicking more, but Vaadin sees that, oh, we're still waiting for the server, so it put all the other clicks in a queue, and then after 2 seconds, that original request was processed, got back, we showed it was this result of 3 label, and then the other remaining 4 clicks from the queue, only then they were sent in a new request, this one, and that one then 4 times run the click listener. Each one took 4 seconds to run, 2 seconds to run, so only after 8 seconds we get the response back that then added 4 of these labels. This is clearly not what the users would want. So what do we do? The thing we need here is, it's kind of obvious. We need to do the slow processing, we need to do it in a background thread. Somehow do it asynchronously. How do you do that in Java? If you just use vanilla Java, there's a couple of ways. For instance, you can just create a new thread and start it. You shouldn't really do that usually because a thread is quite expensive to create and so on. So you should instead use a thread pool that reuses the threads just to save some resources. You can, for instance, there's executors class that factory for lots of different thread pools implementations, or then there's also nowadays a fork join pool, which is kind of a bunch of threads that are shared with whatever else is going on in the Java virtual machine at that point. So you can use those. If you're using Java EE or Spring, then because the way those frameworks need to intercept things, you should instead, for instance, use a managed executor service or annotate your specific methods with async, or use message beans or whatever. Then also if you use some really kind of fundamentally asynchronous framework like Akka or RxJava or something, with those they all have their different ways of doing things asynchronously. In my example, we're just going to do it really easy. So we're going to use a basic thread pool. We're going to do, well, actually, let's do it here. Executors, new cached thread pool, and that's our pool, and no private, static, and final, just to be safe. So here we have our thread pool, and then now what we want to do is to take, this is the slow thing that we want to do in a background thread. So let's do pool.execute like so. But the thing is, we still want to get the result out somehow in the same HTTP request, because what goes on, no, actually, that's wrong. It's the do it part that is slow. But the problem is that we cannot up that label here now also, because it's it happens too early, so to say. So what we can do instead is, this is just an example again, users wouldn't really like this, but we can create a button. Is it done yet? Question mark. We add this to the, no, actually we need a click listener on it with a click event, and what we do there is that we see that if the job is done, then we update the label. So that's basically this thing, except that we don't have it. We must do job.getResult, and then we can also show progress here. So else we set the value to job.getStatus, yes, and then we need to add this button also to the layout. So now what we can do, let's refresh this, let's close this also. What we can do is that we click, and then we have is it done yet button, and then we click it, and now it says, okay, this is done. If I'm slightly faster, then we can see that 43%, oh, now it's done. So in this way, yes, the users can see, is it still done, is it still done? This is still not what the user would want. This is just kind of an intermediate step, of course. What we really want to do is to have Vaadin do this automatically, continuously browser sends a new request asking, is it done yet? And then we update the status based on that and then keep doing that. And of course, there's a built-in feature for that. It's called a poll interval. So we can do here when we start this in the background thread, we also do set poll interval, for instance, 100 milliseconds. And then we add a poll listener, which is called then every 100 milliseconds when the browser actually sends something. And what we want to do there is exactly the same that we did in the button. So now we even don't need the button anymore, like so. So with this, now when we try this, click the button, we see that it updates, and now it says that it's done. Great. Is this the end of the presentation? Not really. The first problem we have is that this thing keeps polling and polling and polling and polling until we say to stop. But I didn't do that, so, well, I don't know about your servers, but my server doesn't really like this in the long run. Let's actually even refresh this one so it stops polling. What we really need to do in this kind of approach is a little bit of bookkeeping. When we start the job, we start polling, and then when we're done, we stop polling, of course. But then in this case, this gets a little bit complicated, because what if we have multiple jobs running at the same time? Then we need to know when the last one has stopped and so on. So we need a bit of bookkeeping. Basically what we need is a map of these jobs, and we map that to the label that we should update once it's done. Jobs, and this is just a basic hash map, nothing fancy. And then what we do here, instead of always setting the poll interval, we only do that if we don't have any jobs running right now for this UI. So if the jobs is empty, and then we set the poll interval, and then we add this jobs, put the job and the message label to update. Well, you can do it that way also. And then we move the poll listener. We have only one of those, which is for the whole UI. But what we also need to do here then is that we need to look at all the jobs that we have running right now and update the status label for all of them. So basically jobs dot for each. This is a callback that gets a job and a message label. And like this, hopefully, yeah. And then finally, if the job is done, we do jobs dot remove this job, and if jobs now is empty, this is the key thing, then we do set poll interval -1. And then also, because we're updating this hash map while we're iterating over it, we need to actually iterate a copy, so new hash map like this. And now when we run this, we see that we can start polling, and then it stops sending requests after a while. And even if we start multiple of these, of course, because I don't do bugs, it just works. So that was polling. Sometimes it's the right thing to do because it's really lightweight, it's really simple. It's basically just every now and then the browser kind of emulates clicking that button for you, and then you can react to that, update status and whatnot. One thing you have here is a trade-off with the poll interval. If you poll really often, then the user will see what happens immediately, but you will also be putting a bunch of load on your servers. Sometimes you want to do things in a completely different way. Instead of having the browser ask like, what's up, what's up, what's up, you could also actually have the server say that, hey, now there's something for you without having to poll for it. So then we come to this thing about pushing out updates instead. In that way, the user can see the results immediately when they happen instead of after the next poll interval. To see how that works, we need to look at different, again, kind of what goes on over the network. So with polling, the thing we had previously, the browser sends, do you have any updates? And then the browser just quickly checks, and then it either responds back yes, or then there's an immediate response saying no. One variant of this is called a long-running HTTP request. So it's still the same thing. The browser asks, hey, do you have any updates? But the browser just say like, please wait. I'm not sending you a request yet. But then when something happens, when there is an update, then the browser actually sends the response back. So the client just waits for a response. Of course, at some point there's a timeout and so on, but basically that's the approach. And in that way you can react immediately. There's also a more kind of efficient way of doing this, which is called WebSockets. So it's a browser feature that lets you open a bidirectional, kind of like a TCP socket between the client and the server. So with that one, the connection is always open. The server can at any time say that, hey, now I have some updates for you. Now I have more updates, even more updates. And as I said, this is bidirectional, so you can also have it so that instead of sending regular HTTP requests, when the client wants to say something to the server, those can also be sent over the WebSocket. To use all this in Vaadin, it's really easy. You just add one @push annotation to your UI. So let's do that. Oops. I will actually remove all this thing about polling. We don't need that one anymore. We just need to do @push, and then instead here now we can just update things and then hopefully Vaadin will take care of pushing that out to the browser. So let's try this in practice. We see actually here that yes, we do have a WebSocket connection open here, but we also see that I click the button and I wait and I wait and I wait and nothing happens. I go back to my editor and I see some red. I see an exception saying that the session must be locked while blah 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 blah. The problem here is that yes, we need to do always when we do things in background threads or asynchronous or whatever, we have to ensure that multiple things aren't happen in the same time so that things kind of step on each other's toes. The way you kind of in principle would want to do this is that first you acquire some kind of lock to ensure that this is nobody else is touching these parts of your memory structures, and then you do whatever changes you have. And then in the Vaadin context, you need to actually push out those changes over the WebSocket to the browser. And then you need to have this in a try final block so that you always unlock, because otherwise things will break down even more. This is a bunch of boilerplate that you don't want to do. So instead, you can also basically get rid of the boilerplate. Just say to Vaadin, hey, just run this callback asynchronous, and after that push out any updates. So then you can just, okay, you write a lambda, that's still a couple of bytes of overhead, but not too much. But still, in the big scheme of things, this is more compact. This still has one small problem, which is that in most cases we don't even, there's no need of waiting for the lock, because we don't need to get a return value back. If the lock is currently, if someone else has already locked this thing, then we just let someone else take care of our stuff later. So what we also have in Vaadin is just access, not synchronously. So what it does is that if the lock is available, then this callback is run. I don't remember, is it really immediately or really quickly, but still asynchronously. But then if the session is locked, then someone else will take care of running your callback at a convenient moment in time, and you can just keep on doing whatever else you are doing. You don't have to wait for it. So let's put that into practice. So actually in our example application, use this access method. It's defined on the UI class, by the way, and then also get those status updates back, the things that show the percentage while the job is running. So what we need to do here, we're doing this now in the UI, so we can just immediately do access, and that one gets a runnable, so just a basic lambda callback in my case, and I just move this set value into the access callback, and now if I do this again, wait 2 seconds, and then we see that here we have the result. Also, if I look at this WebSocket, we basically see that, well, first there's some really weird message, which was just a handshake. Then we have one outgoing message, which was when I clicked the button. And then we have 2 incoming messages. First one, it's kind of 10 milliseconds after clicking the button. That was the one that added the label saying that what button clicked. And then almost exactly 2 seconds later, give or take a couple of milliseconds, we get another message over the same WebSocket without us having to send another request or anything. And that was the one that actually added the result to this label. So that was that. Now we also want to get these status updates back. For that we can do job has an on update callback that is run whenever there's an update to the status. So what we get here is a status, and what we want to do with it is we want to show it in the same label. So do message set value status. Great. It compiles, so it must work. Click the button. I don't see any statuses, and I don't see any updates or the result either. But what I see is lots of stack traces again. Because I again forgot to do locking, and this is something that you will also be doing every now and then. Always remember that when you do things asynchronously from a background thread or something, always use UI access. And if you don't, you will, if you have luck, you will get this exception. If you don't have, then that's what we're going to see now. Because what the framework could be doing is that whenever you touch anything that might be dangerous, anything that might need locking, it could just check like if it isn't locked, then we throw an exception. The thing is that there are lots of potential places where this should happen. And this kind of check, it's not really expensive, but it's not absolutely for free either. So what we're actually doing is that we use the assert functionality in Java. This means that when the class is loaded, Java sees that are assertions enabled or not for this class, and if they're not enabled, then it completely ignores the assert statement. It's as though it wouldn't exist there. But if assertions are enabled, then Java will actually run these checks for you. So in this way, you can run with assertions enabled when developing, and then in production, where you want to have all the performance out of your servers, you don't have assertions enabled. That's, by the way, the default. And in that way, you can have kind of the best of both things. So to actually use assertions, you need to run Java with the EA, enable assertions flag. So let's try turning off assertions in our example and see what happens then. So I will modify my launch configuration, and I will remove the EA flag that I put there on purpose. There we go. No, I was just slightly too fast. So still, we see that, okay, now I didn't get the intermediate results because I didn't use UI access for those, but I did get the final result. What we also see is that I didn't get any exceptions. But there's one more interesting thing here, which is if I click the button again while the job is running, like so, then when I click, then I do get some update. And also when it pushes out for the actual result, then also the status labels are updated. And if you have these kinds of symptoms like nothing updates that should update, but then when I click the button or do anything else with the UI, then suddenly the other results show up, then it's most likely it's a symptom of, well, either the WebSocket is just broken, or then you have forgotten UI access somewhere, and the way of finding where that is exactly to enable those assertions, and then you're good to go. So let's now fix this, but by also using access here for the updates, and I'm missing a parenthesis there. Great. So again, this works. I don't do code bugs except on purpose. And why doesn't it find this one anymore? Well, so No. Now Java is doing something funny with me. Well, now it works again. Great. So that's that. Now let's talk a bit about these different HTTP transports kind of things. So if you don't use push, what happens is that when something is initiated by the user or by the web browser when using polling, then there's an HTTP request for that, and then whatever the update is in the response to that request. If the server wants to do any updates, that's not possible because the server doesn't have any way of doing it. When you enable push, there's some setting used by default, but you can also choose what transport to use. By default in Vaadin 7 and 8, there's this transport called WebSocket is used as the default one. For that one, there's always just one WebSocket connection used both if things happen in the browser or if something happens on the server that is pushed out. All that communication, everything goes just to one single WebSocket. This is usually good, but there are some edge cases when WebSockets are slightly fragile, and then it's quite bad if nothing works. So there's also this alternative WebSocket XHR, which is just kind of mixing WebSockets and HTTP requests. So if something is triggered in the browser, then we send an HTTP request and get a regular response back. But we also all the time keep a WebSocket open in case it works for those updates that should be triggered from the server. This is the default starting from Vaadin 10, because again we learned that this is on average still better. Then there's also a fallback thing if you, for instance, behind some HTTP proxies or with really old or broken web browsers and so on, WebSockets just can't work. And for that, Vaadin by default automatically uses long polling as a fallback. So with that thing, HTTP requests when the user does something, but then there's also always a long-running HTTP request, this long polling thing that is used in case the server has something it wants to push out. More things that you can go wrong for you. So far I have kind of cheated because I have done everything just in my UI, and the UI class is the thing where the access method is defined. If I instead make this into a real application, I would even say a real enterprise application, so we have separate classes for everything. So I will have a my layout, which is a vertical layout. And in the constructor for that one, we do all the things we did in the UI before. And then we need to update this one to actually use my layout instead. Now I forget some white space. It should probably be there. No, where should it be? I don't know what white space that was. Oh, it's no, it's the end of the click listener. Ah, there we have the end of. Now it's almost fine. No, there's still some compile error. This is not fun when you're live coding. But I don't do bugs, remember that. This is what I'm missing, the end of the constructor. And this is just this now. But what we have now is that access doesn't exist in this context anymore. What I could be doing, actually let's do it, is to do UI get current instead. Let's comment out this one just so we have less things to worry about. So just get the current UI and access that one. And if I try this out, I still have some compile errors. No, I don't. Yes, I do. I don't need those. Let's restart the server. So now when I click this, nothing again happens, and I get a lovely null pointer exceptions. Because UI get current is not defined again in this asynchronous context in this background thread. What I can do, but I shouldn't, because we're inside a component, so we can do just UI, this.get UI. This will probably work, but I shouldn't do it. The reason is that this is not thread safe. Get UI, it kind of follows get parent, get parent, get parent, and then if some other thread at the same time does something, then bad things can happen. In most cases, it will work, and that's the dangerous thing. But still, what I need to do is to actually run get UI in some safe context, like immediately in the click listener, because then Vaadin takes care of doing all the locking for me, and then it's safe to do it. So I do that in some safe place, and then I just reference it in some other place, and then that's a good way of doing it. So now I can also update this one. This is easy in theory, but in practice it can still get a little bit complicated. One case when you might encounter that is if you're not the one that immediately manages the background task. Like here I just create a runnable as a lambda and just pass it to a thread pool. But what if there's someone else managing this asynchronicity for me? So for instance, if we have a job.start, which just takes a consumer that will be run when a result is available. Oops. So we have the same kind of structure. We need to use UI access here also. This in itself would still do exactly the same thing, but as I said, we're doing enterprise Java development here, so we need more classes. And these anonymous classes, no, they're not enterprise enough. Let's create a real nested class here, a proper class. And what we see here is that, yes, here we have the accept callback. And for it to be able to find the UI and the message label to update, in this case, the IDE generated for me a constructor where those are passed. And in some cases, you might have like multiple levels of passing things around until you actually reach the part that actually start the asynchronous job or whatever it is. And in those cases, you most usually should kind of, from the click listener that starts everything, collect all the Vaadin things and just pass them along the whole chain, because otherwise you will have problems. Let's get back to a little bit of theory. That UI get current that I showed you, that didn't work. The reason for it is that it uses something called thread locals. That's again a fancy Java feature. It doesn't really work in this way, but you can imagine it works so that there's a global map from a thread instance to a UI instance. So for every thread, when you do get current, UI get current, it looks from that map, uses the current thread as the key, and then it gets the UI instance out. This means that someone always need to, before running your code, they need to put that UI instance into the map, and then also to avoid leaking memory, someone needs to remove it afterwards, because otherwise you will, that UI instance will be leaking memory. And to make things even more fun, there are two different variants of this. One is just thread local, and then there's a thing called inheritable thread local, which means that if you start a new thread, then it will inherit all the current thread local values from the owner thread. In Vaadin 7, we used this inheritable thread local for UI get current and Vaadin session that get current and all of those, because it's really convenient. You start a thread and you can still use UI get current there. The problem is thread pools, because then suddenly threads can be started in different ways, and eventually you will end up leaking memory with those inheritable thread locals. So for that reason, we changed it starting from Vaadin 8. We just use regular thread locals, which also means that if you migrate from 7 to 8 with this structure, you will get null pointer exceptions, because suddenly the UI get current doesn't exist anymore. But such is life, and now we at least we don't leak memory anymore. Next up, one more thing that can go wrong in this still really simple example. Let's just see that it still works. Yeah, it seems working. The thing that still can go wrong is if I click the button and immediately refresh in the browser. Okay, here it seems to work, But then when I go back here, we again have a whole bunch of exceptions. They come from on update UI access. The problem is that when I refreshed in the browser, Vaadin immediately knows that the old UI instance can be discarded, detached, and so on, and we create a new one for the new refreshed context you have. But the problem is we still have a background thread trying to push things into the old one, and that throws exceptions so that you will actually notice that you're doing something that you should maybe avoid. So what this means is that, well, the first thing you can do is just catch the exception and ignore it because, well, enterprise Java, right? But, I mean, it's the least you can do. In many cases, you can do things a little bit better. You can also stop the actual background processing because there's no user who will ever see the results. And in many cases, you can do it even one step better, provided that you have some way of stopping the job, for instance. So what you can do is that when in this case, my layout component, when it's detached, which happens also when the UI is detached, at that moment, you can also stop the job. So just a basic add detached listener. We get some kind of event. I don't care about what event it is now. And then we just do job.abort. Like, isn't it abort? I don't remember what the name is, but I won't demo this. So, but that's something that you can and should do if you just have the possibility to stop the background processing as early as possible, just to avoid wasting CPU cycles on things that won't do anything. So that was push. Really easy. You use it usually when you have some kind of background work, and then once it's done, you want to just show the result to the user. Behind the scenes, this uses either WebSockets or long polling HTTP requests, depending on circumstances. When you use this kind of technology, you need to remember to use access for proper locking and actually pushing things out. You should remember to enable assertions so that you will notice when you forget to access. And then there are some gotchas with getUI and when the UI is detached. But they are kind of not that difficult still. Last thing I want to show you is when we have like things continuously updating, not just waiting for one thing to update, but all the time things happening. Maybe there's some, I don't know, event stream, or it can be many different things. Basically, this is the same. You have push, you have WebSockets, you do UI access whenever you want to update things. But there are a couple of special things that you also need to take into account here that I will show you now. To do this, we will build a simple chat application. How hard can it be? So let's remove some old stuff. Instead of a my layout, I will use a chat layout. I cheated a little bit. That looks redundant. Yeah, I cheated a little bit. I did the kind of UI already for you. This chat layout component, it also needs a callback that is run when a new message is posted by yourself. So we get a new message, and what we should do there is to inform all the other chatters about this new message. And I actually cheated a little bit more, so I prepared a really simple chatters class. In a real application, you probably use like some existing event bus, some publisher subscriber pattern, or Redis or whatever for doing this kind of stuff. But right here, I'm doing things really simple. So we have a concurrent set of chatters, which are just, again, string consumers. We can register a new one. It returns a callback so you can unregister yourself. And then there's a helper just for doing something with each of those chatters. So what I want to do here, when we get a new message, I do chatters.forEach. And what I want to do is remember no. Let's not get ahead of ourselves. We just do chatter.please accept this message. Yes. And then what we also need to do when we are initting this UI, we will add ourselves as a chatter. So chatters.register. And here we get a new message. And what we need to do is to say to the layout that let's add this message, let's show it. And this needs to be imported. Now Java is again messing with me. This one also, please recompile, and now it's happy. What I also need to do here is actually to run this without JRebel, because this chatters global array will not play nicely with JRebel. So we need to do the non-automatic updates here. And what we have here is nice chat application. I can say hello to myself, and it shows that I said hello to myself. The problem here is if I have another person also chatting, also saying hello, hello, and where is my mouse? There's my mouse. I click the button and we get a blue error message because something is not locked. Because what happens here, we're not doing background threads, but we have two different UIs, two different sessions trying to talk with each other, and that's again a good way of causing race conditions in your code. So we also need to do locking here. So what we need to do is UI dot, no, just access here, and so on and so on. And then we need to remember all the things from before, like unregistering and all those things. And this is again really boilerplate, the same pattern repeated over and over again. So actually I cheated and created an add-on for this, and I really recommend that you use it also if you have the same thing. So what I can do is that I say accessor.ofConsumer, and this one will take just anything that should be run in the UI with the session locked when there's something to react to. In this case, that's just layout add message, because we just get a string and we add it there. And then we need to have a subscriber, something that when this component is attached, we start listening for chat messages, and then when we stop, we stop listening, or when it's detached, we stop listening for that. So here we have a subscriber, it gets some kind of consumer, and then what we need to do is to register that. So no, actually we can, not chat layout, chatters register this consumer, and then this one will also return a registration, which we also need to return. So return that one, and then we bind this to, for instance, well, let's bind it to the chat layout. And with this add-on, this small pattern, it automatically takes care of actually running the returned unregistered registration and so on. And in this way, we can avoid lots of boilerplate. But that's not the fun part. The fun part is that this now is, well, actually, let's verify that this works so that we don't get into trouble. Redeploy. And now I can say hello in one browser window, and the other browser window also reacts immediately. Awesome. But this is not how easy things are for real, because what if there are 1,000 chatters, or it actually takes a while to process things and so on? Then we will still get some problems. I will emulate this by doing here for each chatter. Let's pretend it's lots of chatters. So we will just sleep a while here. And again, good old catch and ignore pattern. What we see when I redeploy this thing is I say hello, and in one of the browsers it's updated immediately, but in the other one it takes a while, and actually even it doesn't, because it takes so long to run this whole hey, we have a new message callback, and only after running that one we can clear this text field. So if you see when I press enter, the old text is still there for a while until now it disappears, and that's not good. That's again not what users like. So what you most cases have to do, in many cases if you use a real chat backend, it's taken care of for you already, is to do this, notifying everyone else, doing that in a background thread also. So what we can do here is pool.execute, and then we take this whole thing and run it as a background thing. And now let's see what we have. Now when I say hello, it still doesn't work. And there's a reason for this, of course, because I don't do bugs except on purpose. The problem here is that still each of these updates takes some time. So the way of kind of cheating around this is to just switch the order. So for each chatter that we need to notify, we do a separate background job. You might maybe not do like one for every, but one for each 10 or whatever, or have, again, a real backend will manage these things for you probably. But now when we have this kind of setup so that we put all of those into the thread pool, one job at a time, and then now we actually have, despite the latency, we have a real-time chat again. So that was continuous updates. It's basically the same as just one time pushing out things, but most cases you need to take care of how are you asynchronously also delivering messages, making sure that no specific part is locked up for too long and so on. One thing I also want to mention that I didn't show is that in these kinds of situations, a chat is quite straightforward, but you need to take into account, like in the UI design, how things are updated so the user understands what's going on. Because if stuff just suddenly moves around, the user might be quite confused. So maybe just show a small notification or whatever. So any questions on this topic, or will you again do so that then when I say thank you, then you start asking?
Question. In Vaadin 10, when you set add push annotation in conjunction with Spring, and when you do logout, and then you log into the application again, you were always redirected to /Vaadin servlet. So the context path on a logout was somehow set on Vaadin servlet. I even made a case on Vaadin website. Nobody responded from the community.
Interesting. So, okay, someone has done a bug. I don't know if it was me. Yeah, I don't know, just based on what you described, but that sounds like a bug, and it sounds like...
Well, I was not the only one, because I figured out 3 or 4 other people with the same
yeah, sure.
problem.
It's probably, if you have that set up, yeah, it sounds like something that should need some attention. Yes, yeah. I agree.
But it's not something that rings a bell?
Not immediately, no.
Okay.
Any other questions?
Yes.
Yes?
You showed that on Vaadin 8, right?
That was showed on Vaadin 8 because I needed the preserve on refresh, detaching the old UI immediately when I refresh kind of feature.
But it all works on Vaadin 14.
Everything else works exactly the same on Vaadin 14 or on Vaadin 7 also. Except that it's you shouldn't use label in Vaadin 14. Anything else? Or should we have a break until the next exciting session about JavaScript? Everyone is so eager to hear about JavaScript, so there we go. Thank you.